Alright, today we're going to be going over a couple basic examples of the Laplace transform. What the Laplace transform allows us to do is if we have some function, f of t, we can transform it into a function in terms of s, where s is an imaginary or a complex number. The formula to do this is very simple and isn't any more difficult than a regular integral. What we get is that f of s is equal to the integral from 0 to infinity of our function f of t times e to the negative st with respect to dt. It's important to recognize that we're doing this with respect to dt because that means that s is just a constant. When we're doing a problem like this, if we're given a function f of t and we're asked to find the Laplace transform of it, we simply plug f of t into this formula and complete the integral like usual. We'll do a quick example here. I'll show you if we have f of t is equal to 1, the simplest function. All we have to do to find the Laplace transform of this is say that f of s is equal to the integral from 0 to infinity of f of t, which is 1, times e to the negative st dt. Now, if we look at this integral, we can treat it as if it's e to the negative t times some constant, because we're integrating with respect to t, and s is just a number to us. So what this gives us is that f of s is equal to e to the negative st, because the derivative of e to the anything is the same, divided by negative s. And this is all within our bounds of 0 to infinity. Now, if we evaluate this and plug in infinity and 0, we get negative e to the negative s times t, where t is infinity. It's just e to the negative infinity divided by s, and then we're going to do minus negative e to the negative s times t, where t is 0. So this just gives us e to the 0 divided by s. E to the negative infinity is the same thing as 1 over e to the infinity, which is going to be 0. So what we get is 0 minus a negative number, so really plus e to the 0 is 1, so 1 over s. And what we get is that the Laplace transform of 1 is equal to 1 over s. This idea can be expanded on very easily if instead of f of t is equal to 1, we wanted f of t is equal to any constant number a. All we would do is go back to the start, and instead of writing a 1 here, we would replace it with an a. And what we can do to make our lives easier is simply factor out this a. And what we're left with is just a times the integral we just did. So if we work our way to the end and everything is multiplied by a, we're just left with f of s is equal to a over s. Another example, a very common one, is if f of t is equal to e to the at, where a is just a constant. If we want to find the Laplace transform of this, we just plug it into the formula. Get f of s is the integral from 0 to infinity of f of t, which is e to the at, times e to the negative st, all with respect to dt. If we use our exponent rules, we can simplify this a little, and we get f of s is equal to the integral from 0 to infinity of e to the negative s minus a times t, all with respect to dt. This might look like a bit of a weird way to write it, but what this lets us do is this is just a constant in our mind. And so the integral is very similar to the one we just did. And it gives us f of s is equal to e to the negative s minus a times t, all divided by negative s minus a, from 0 to infinity. When we go to evaluate this, what we get, moving this negative up top, is negative e to the negative s minus a times infinity divided by s minus a, minus, but this negative is on the bottom, so it's really plus because we have minus minus, e to the negative s minus a times t, where t is 0, divided by s minus a. Now if you see here, this is again going to be e to the negative infinity, which is going to end up being 0, and it leaves us with e to the 0, which is 1, divided by s minus a. And that's how we end up with the Laplace transform of e to the at is just 1 over s minus a, where a is any constant. Hopefully this gives you a quick overview on how to do a Laplace transform and have two example functions.